Hello and welcome back to Sheaff Math. In today's lesson, you are going to learn about trig function ratios and the mnemonic device SohCahToa. We'll talk about that in a second. So before we get to SohCahToa, let's look at some very important features on a right triangle. Okay, so you know the right triangle has one angle, which is a 90-degree angle, and the three sides are going to have very significant importance in relation to certain angles. So just if we were to look at this angle right here in the left bottom corner, the three sides have certain names for them. And so of course, the hypotenuse will always be that long side that's across from the 90-degree angle. But the two new ones are opposite, which is the one across from the angle we're looking at, and so A is the opposite side, and B is called the adjacent side. Okay. Now let's say we were looking at this angle up top right, then the hypotenuse is going to be the same. C, it's always going to be that long side, but this time the opposite of that angle is B, and the adjacent is A. Adjacent means it's right next to that angle, or it butts up to it. So now, what is SohCahToa? So as I kind of talked about, it's a mnemonic device used to remember the three main trig functions. Okay? And it's spelled like this, and each letter represents something. So first off, let's talk about the S represents sine, the C represents cosine, and the T represents tangent. Okay, and so those are the three main trig functions, but we're going to look at them individually. Now sine, the ratio of the trig function is the sine of an angle equals opposite over hypotenuse. Now that little sign there is called the theta sign, and we use that as kind of like any angle. So the sine of an angle equals opposite over hypotenuse, and if you notice, SOH. This is the order that we're looking at. And so that's the first three letters of SohCahToa. The second ratio is the cosine ratio, and that is adjacent over hypotenuse. So CAH. Then the third one is tangent. And the tangent of an angle is equal to opposite over adjacent. TOA. So you can see how this is going and what SohCahToa represents. And so it's important for you to memorize this. It's helped so many math students. It helps me. That's what I think of when I'm trying to remember the trig functions. And so it's good to know. So let's just do a little recap and show you exactly what this means. So the SOH represents sine equals opposite over hypotenuse. Ka represents the cosine equals adjacent over hypotenuse. And Toa represents tangent equals opposite over adjacent. All right, now we're going to find out what we can do with this. So let's find a few ratios in real triangles with values. So suppose you were asked to find the sine of t. What does that mean? Well, here we have a right triangle, the famous 3, 4, 5 triangle, and t is an angle, and we want to find the ratio or the sine of t. And so from this angle, as you can, if you remember, sine equals opposite over hypotenuse. So we're looking for the opposite side and the hypotenuse, which is 5. And so the sine of t equals 4 over 5. And that can simplify to a decimal of 0.8. And so this is finding the ratio of a trig function. Let's try another one. Suppose you were asked to find cosine of t. Same triangle. So we're looking at this t here. And now we want to find cosine, and this is equal to adjacent over hypotenuse. So the adjacent side is 3, and the hypotenuse is 5. So the cosine of t equals 3 over 5, or simplified to a decimal, 0.6. And that's our ratio. Now, suppose you were asked to find the tangent of W. So the same triangle, we'll look at W now. So that's this angle. And so tangent is equal to opposite over adjacent. So opposite is 3, and the adjacent is the 4. And so that's our tangent. It's 3 over 4, which works out to 0.75. All right, let's look at a more complicated question that you might come across. Suppose you are asked to find the sine of W. Now I have a different triangle this time, and you can see I have different numbers. And so as you can recall, the W here is right there, and we're looking for the sine, which is opposite over hypotenuse. But we have a little problem. Our opposite value is missing. We don't know what VT is equal to. So we're going to have to do a little side problem. And so we're going to use the Pythagorean theorem. And as you recall, a squared plus b squared equals c squared. And we'll take the two legs. We have 7 and then the missing value. So we'll put 7 in for a, b is missing, and then 10 is the hypotenuse c. And we're going to solve. So we get 49 plus b squared equals 100. We subtract 49 on both sides, leaving us b squared equals 51. And we square root both sides, giving us b equals square root 51. Now the square root of 51 can't be simplified anymore, and so we're just going to leave it as square root 51 because that's the exact length of it. And so now we're going to do the sine of W. So what we're going to do is we'll find the opposite of that angle W, which is square root 51, and the hypotenuse is 10, and so the sine of W equals square root 51 over 10, and you can actually put this into a calculator and get a pretty close answer. And so I rounded it to 0.714 to the thousandth, and so the sine of W is approximately 0.714. And there you have it. You learned to find the ratios of trig functions, and you use the special device called SohCahToa to remember. So take a picture of that and memorize it, remember it. And well, thank you for watching, and we'll see you next time.